The number of books in an item, not the total books on there. Anything else anybody can think of project one wise? Okay, well, let me shift over here and talk about project two. Again, we're not put a project out before the previous project is due, but with the weekend and holiday and so on, I gave you a little bit more time on project one. This is a project dealing with the multiple threads. So we're moving on beyond that now. So I want to get this project out for you. You can start working on it. It is very much related to the producer-consumer problem that we went over in the notes. Can't remember actually if I put that code out there yet or not. If I didn't, I will do that today. So you have it kind of as a basis to operate on. This one is, you're going to kind of simulate a bank account, access to a bank account with withdrawal and depositing threads. So the synchronization of the lockable object you're synchronizing is the bank account, namely the balance that's in the bank account. So withdrawal threads take money out of the account, deposit threads put money into the account. The synchronization comes in the sense that because the account is shared by all these different threads, you have to guarantee mutually exclusive access. So no matter whether you're a depositor or withdrawal, when you want to do something to the account, you have to lock it. Okay? You're the only one that gets to deal with the account at the time. You do whatever you're going to do with it, and then you release the lock. We're going to add some complication to this because just synchronization is not quite enough to really appreciate what you're doing here. So we'll keep it kind of simple so you can really see and understand what's happening. We're going to put the depositor threads so that they deposit amounts between $1 and $200. Okay, we'll only do even dollars, don't worry about the cents. Withdrawal threads, when they run, they will withdraw, again, some random amount between $1 and $50. Again, only even interval amounts. You're going to have 3 deposit threads, and you're going to have 5 withdrawal threads running, accessing on this particular account. Now, again, to kind of simulate just random behavior when the threads are running, when a deposit thread runs, that is, when it gets the lock, puts money into the account. After it does that, we're just going to put it to sleep for a random period of time. Okay, we don't want it to just immediately keep going back and being runnable. So deposits, sleeps, deposits, sleeps. Essentially, what we want to see here is a lot more withdrawal operations than deposit operations, because what I want to show is that a depositor, after they put some money in, withdrawals will start, and as the withdrawals run, they will bleed the account down to the point where there's insufficient funds, and they will be blocked at that point, waiting for a depositor to put more money into the account. So I'm going to come back and talk about this paragraph in just a second. We're going to assume that all the threads have the same priority. It doesn't matter whether you're a withdrawal thread or a depositing thread. Everybody has the same priority. You don't want to use a counted loop. Okay? In other words, your run methods for your threads are just infinite loops. They just run. Okay? So you start the simulation running, and after you get tired of looking at it for a few seconds, okay? And at that point, you just basically look at what's happened, because they will run forever just adding and taking money out of the account. I also don't want you to use Java's synchronized state monitors. In other words, you're going to do it all at the low level. You're going to deal with the locks. You're going to deal with the signaling on the lockable objects. So the condition variables and all that we talked about, you're going to be handling. It's not going to be part of the synchronized method. Let me kind of show you what's happening here. This is what your output's basically going to look like. Again, you're going to probably the way to do this, which is similar to what I did in the notes. Just set up a thread pool. In this case, we're going to have 8 threads in the pool. Just start them all running. Give the executor service the ability to just start them, and they all are created from their constructors, and they all start. You can see in this first simulation here that thread 1, I gave all the threads numbers so you can keep track of who's what. So 1, 2, and 3 in my case are deposited threads. 4, 5, 6, 7, and 8 are withdrawal threads in my case. You can see the 2 columns there. So we start out with 0 balance in the account. So if it would happen, didn't in this case, but if it would happen that a withdrawal thread would run first, then it would immediately block because there's no money in the account. I can't withdraw any. It would block. In this case, a depositor got in there first, put $122 in the account, and then the next thing that happened is thread 4 comes and withdraws $34. That's perfectly fine. And then you can see the give and take that continues on back here, and then eventually what happens as the withdrawal threads, at this point, all 3 depositor threads have made a deposit, and they're all sleeping now for some random period of time while these withdrawal threads are running, and they basically bleed it down so that when thread 7 here tries to make a withdrawal, it will discover that since there's only $30 in the account and it tries to withdraw 33, that it's going to overdraw the account. So we're blocking it at this point. So it blocks itself, much like the producer-consumer problem we dealt with. Depositors here are producers, withdrawal threads are consumers. So it's blocked, and what is it waiting for? It's waiting for a depositor to put money into the account. And until that happens, it is off waiting. Okay? It's not going to come back and try again. It simply is blocked. The next thing that happens here is thread 8 also attempts to withdraw money. It also is blocked for the same reason. But notice here that thread 6 actually tries to withdraw an amount that is still less than what's in the account, so it's allowed to do that. Now in this simulation, I actually put in this 0. You don't use a 0 number on yours. I wanted to see that even though the account was at 0 balance, since we have a thread that's trying to withdraw 0 amount, it will still execute. Okay? I'll actually take anything out because there's nothing in there, but it's not trying to get anything either. So you're just going to be using 1 through 200 for deposits and 1 through 50 for withdrawals. So at this point, as this continues on, eventually right here, all of the withdrawal threads are now blocked. Okay, everybody has attempted to withdraw more money than is in the account, so they're all blocked. They're waiting at this point for some depositor. We don't care which depositor it's going to be, but one of them will eventually wake up from its sleep. It will go, and at this point, it's guaranteed to get into the account because everybody else is all blocked. So the account's available, it unlocks it, or sorry, locks it, and it's going in. And what does the depositor do at this point? It signals everybody that's waiting on a can withdraw condition. Okay? I put money in there, you can now go and take money out. It doesn't signal any one particular thread, it just wakes them all up by saying, hey, deposit's made, signal everybody that happens to be waiting on this condition. They will all rush off to go executable at this point, and as it turns out, with withdrawal thread 5 happened to get there first, and it finds enough money in there and continues on. So this is, again, basically a classic producer-consumer problem, kind of couched in a little bit different close, if you will. And then I want to talk about this paragraph that I skipped over. You're dealing, of course, with synchronized, cooperating threads. And we talked about this when we were first dealing with threads as to whether the CPU is a single CPU or we have a multi-core processor. And the simulation you're doing here will actually be affected somewhat by your hardware. If you are working on a single core processor and you have a withdrawal thread executing, in other words, it gets the CPU, so it's now starting in its run method and it's going to start withdrawing money. It makes a withdrawal, and its run method is a continuous loop. Okay, we put it to if we just allow it to continue, it's just going to sit there in the same thread, the same withdrawal thread, just going to keep pulling money out of the account, and it would very easily bleed it down to 0 before anybody else got the chance to even ask for money. We don't want that to happen. So we have two options as to how we control that a little bit. And the first option is if you're working on a single core processor. You can simply yield the CPU. In other words, the withdrawal thread has run through its operation, it's gotten money, and now it gives up the CPU voluntarily. It just takes itself out of the runnable state. Goes back. It could be run again because it might happen to be the only scheduled thread. But chances on, with this many threads, chances on a single processor that they're all not available at the moment is probably pretty unlikely. So it would be unlikely to see the same thread run again. Okay? That's on a single core processor. On a multi-core processor, the sleep isn't going to work. Okay? Or sorry, the yield isn't going to work because you may give up the CPU voluntarily, but you are the only withdrawal thread scheduled on that CPU. So you give it up and then you come right back in again. So to kind of, again, simulate maybe giving up the CPU and hoping that somebody else is going to get a chance, on a multi-core processor, you want to sleep the thread. Okay, so the withdrawal thread will get a withdrawal and then it will sleep for some random period of time. Again, that's not going to guarantee that it won't ever run because it might sleep. It'd still be the only schedulable thread on that core, and then it wakes up and is again immediately running before anybody else does it on their cores. So it's not going to guarantee that you won't see something run in sequence. Having said that, also let me show you this picture here again. You notice as you're running down through here that most of the time you see back and forth. Here is a case where thread 5 runs twice in a row. Okay? So whether it yielded or whether it gave, whether it did a sleep, all we know at this point is that it happened to get back into the CPU next and run a second time. So the occasional occurrence of that is fine. Okay, and we would expect that given the kind of structure we have. What you don't want to see would be a whole stream where 10, 12 in a row maybe of the same thread making withdrawals. Okay, if you see that, you're not properly synchronizing things in the sense that it's either not sleeping or it's not giving up the CPU, and it becomes the only scheduled thread. So I put 2 runs of this in so you can kind of see it. They're just, again, it's very random in nature. And when you're executing things like this, when they're all infinite loops, just let it run. It'll go very quickly. If you make the sleep times fairly short, you'll probably have to adjust that a little bit depending on what your processor speed is. If you have a really fast processor, this will execute pretty quickly. Slower, it'll again slow down. So how long you have the simulation to run is up to you. I just took these screenshots and basically when I started it, immediately stopped it. It's filled up 3 or 4 pages of the screen.
Is there any way to parameters that run on different processors the same way, or do you have to just adjust the sleep time up every time?
For a simulation like this, you could do that. It'd be a little difficult. You have to consult, do some system level hardware check to see what kind of processing cores you're running on. There's a way on some systems to turn off multiple cores if you have it, so you can force something to run on a single core. But for what we're doing here, I just really want you to get the give and take, and we can adjust it either with yields or sleeps well enough to get the kind of simulation we want. Okay, any kind of questions anybody can think of yet on this one?
If the thread gets black because of insufficient pod, therefore when it gets, after the pod is made, the thread gets a new value?
You could do it either way. What I did was I just assumed when the thread wakes up again, it just starts back through its run method, and it's going to generate a new random value. You could have it retain the original value if you wanted, but again, for our purposes, there's no real point doing it one way or the other. So I just allowed it to generate a new random value. Okay, so get started on this one. I've got it due on the 20th. That should give us 2 more classes to talk about any kind of questions, and hopefully there'll be at least another 1, maybe 2 times where the TAs will be here. It's, again, based very, very loosely on the producer-consumer things that were in the notes. So what I call the buffer in that case would be the bank account here. And Again, producers would be depositors and consumers would be withdrawal threads. And then you just have some main driver program that gets the threads running and starts the simulation for you. So you don't have any GUIs or anything to worry about this time. Okay? All right, then next thing is we're, like I said, moving on. We want to, it's an enterprise application course, so we want to start talking about all of the details. Certainly threading is a thing that permeates across all of enterprise applications. We're basically constantly going to be dealing with threaded applications, but we need to look at some of the other aspects of these kind of applications. And again, a very common thread across all of these is going to be a database on the back end, or in general, multiple databases on the back end. So this set of notes here is kind of kill two birds with one stone. We're going to introduce you to MySQL, so you can set up a MySQL server, get that all installed and running. And then it's going to kind of introduce you a little bit, maybe more than your database course did, to basic SQL commands. That's not quite as important for you. I just put it in there mostly so you get kind of aware of what we're doing. When we get to the projects and things of this sort, and things we're dealing with in the notes, I will give you scripts which you can execute in the MySQL environment, and they will generate all the database tables and populate the tables for you. When we get into the use of these applications, again, I'll give you script files that will simulate what the user will be doing. So there'll be a lot of queries and inserts and update type operations that you expect in an enterprise application. But other than just kind of being aware of what they're doing and the syntactic things, you won't have to write those kinds of commands yourself. I will give you all of those. But it'll help if you're just kind of aware of what's going on. So the first thing is to get a MySQL and in general an SQL server for your back end. This is basically looking at the back end operations. Again, in enterprise type solutions, we're talking multi-tier architectures. The user tier or the front end will, for the most part, be on very thin clients, PHP, just basically browsers. The mid-tier, the business tier, business logic tier, is where our applications are residing, whether they're PHP or Java-based or whatever. They're there. And then on the back end is the database that are supporting those kind of applications. In the second half of the semester, what we'll be doing is moving a lot of those operations into the cloud. So while you're doing this on your local host systems now, we will be uploading all of this onto cloud-based servers later on. You'll get to see the comparison and the differences and the extra work you have to do when things move to the cloud. But for now, this is going to be a database on your system, whether it's your laptop or desktop. MySQL is supported on virtually all these kind of platforms. The current stable version of MySQL is 5.6.26, and it was just released in late summer. And it is a very powerful database server. It is an open source server for the time being. Oracle has basically bought out MySQL a couple, 3 years ago, and in a sense, then MySQL and Oracle are competing database vendors, but the Oracle's type solutions are generally the more robust, larger type environments, and MySQL tends to be a little bit smaller in that sense. So you don't typically see MySQL systems for very large databases or terra-sized databases. That's where Oracle systems will come into play. So it's probably unlikely that Oracle is going to eventually manage to plug on MySQL being open source. It's a very popular open source, and there are again a lot of variations of this. So as you step through these notes, I'll point out the places where you want to be careful what you're doing when you do this. So go to the mysql.com page, click on Downloads, and scroll to the bottom of this page. There will be a lot of enterprise versions of MySQL and cluster versions. We don't need any of those. We just need a basic, simple database server, and that's called their community version. So click on that link, and that will take you off to the page for this particular variant of MySQL. Again, there will be a lot of different platforms that it'll run on. So when you get to the MySQL community server page for it, again, pick your environment and the platform so you get the right version. The one that I'm primarily stepping you through here is for a Windows version, and it's the all-encompassing installer that they have. The all-encompassing installer, in addition to downloading the MySQL server, it also installs the workbench, and it also brings down the connectors that we'll be needing. So if you do it in this package, you're going to get everything. If you don't use the all-encompassing installer, you'll have to go back and pick up the right pieces that you need, and I'll show you that as you go along. Here's where you get the workbench. The workbench is basically a nice GUI tool that allows you to manipulate, create databases, and kind of become the database administrator of the databases that you're working on. It's easier to do a lot of the database operations through this workbench than it is command line. The MySQL command line really requires that you know SQL commands, not only the DML commands, but the DDL commands and the DCL commands very well. And if you don't know those, it'll be difficult to do the kind of things you need to create the databases and set permissions and so on that we'll be doing. So the workbench allows you to do that. Unfortunately, the workbench doesn't have all of the really fine-grained detail for doing that some of the command line in SQL has. So it's a little bit limited at that point, but for what we're going to be using it for, it will be just fine. Also, you need to go back to the connectors. Right now, we're going to do everything with Java technology, so the only connector we really need is the Java, or the connector J. Later on in the semester, we might be doing some Python. We'll certainly be doing some PHP, but PHP actually connects to MySQL a little differently. There is a MySQL native driver for PHP, but in reality, PHP is much better using MySQL if it does it through the PHP libraries, which are very, very extensive. So for the time being, the only thing you would need will be the connector J. The current version is connector J 5.361, 5.1.36. And I'll talk about that more in the next set of notes when we actually deal with the Java aspect of this. So the first thing to do is, of course, install the server. And again, you're going to see a lot of variations on the install, depending on whether it's a native install or whether it's an upgrade install. For the most part, they'll be similar in the end result, but how they're going to get there will vary quite differently. So these first few pages kind of show you an update, because you may have even had MySQL on your system, not even realized it. And then the initial install can look a little bit different. I'll show you those basic configurations. This is what the installer kind of looks like, and the first thing that's going to come up is all the things that it has already found that you need basically to upgrade from whatever it is to whatever it's going to be. There will be several different things in different packages that will look different depending on what's already on your system. But mostly it will be the server and the connector that we're concerned about right now. The MySQL for Excel it always comes along. It's built into MySQL now. It's basically a way to take spreadsheets and convert them into database tables, and we're not going to do any of that kind of stuff. That's somewhat old school now anyway. So it'll basically start going through and dealing with all the updates. If you get one on this MySQL Fabric, you tell it to get fail on that. Don't worry about that either. We're not going to use the MySQL Fabric. That's something very different. You will have to set a root user password. I would strongly recommend you use something that's very easy to remember. MySQL does not have very many easy backdoors to get in around the administration failure. So if you forget your administrative password, what you'll probably have to do is reinstall MySQL. It will give you a warning if there is a fairly simple password. Just ignore the warning. And what I tend to use for these kind of applications is the root user's name is root, and the root user's password is root. Root is the god as far as MySQL databases are concerned. So basically, we get to this point, and it'll start going through the actual configuration setup, and you'll see these little circles and things will just start getting checked off with green checks as things go by, and eventually it'll say it's finished. You don't need to copy the log to the clipboard. It's going to have, MySQL has extensive log files you can go through, and I'll show you some of that when we need to. But in the end, it's going to show you everything that's installed and configured on your system. And basically at this point, you're ready to go. And you'll see again, the license agreement and so on. This page now is for kind of a new install. Again, there will be slight variations on this, so I would expect that most of you will probably be going through this set of the notes here. And again, there's a lot of options. Most of it is completely changeable once you get past this. So once you get everything installed, if you need to go back and change it, it's still fairly easy to do in MySQL. So what we want to do in this case, there's some different options you could have for this. The developer default is a fine one. The custom is also fine. So is full. Do not set it up as either a server or client-only machine. If you set it up as a server-only machine, you just make your PC a dedicated database server. It's not going to do anything else for you. That's it. And you don't want it to only be a client either. Then it kills everything else on your system, and you just become an SQL client. You'll log in, and all you see will be the MySQL screen come up, and you have nothing else to do. So don't click. The feature selection, again, will be some options here. On a custom install, there will be, again, variations as to what you need here. The main thing is to make sure that you get the server and the MySQL connectors. There's no reason at all to download the documentation. It's extensive online, and you don't need to waste space on your computer with the MySQL manual, which is very big. Again, over here with the connectors, there will be a lot of different connectors. We only really need the Java, the connector J file. So again, on the brand new install, it's going to go through and check off everything that you said to set up for it, and hopefully everything checks out with a nice green check at this point. And you're basically, again, ready. Basically, everything's going to be downloaded and you're ready to go. At any point here, if the server itself actually fails to install, not the connectors or anything else, but if the server itself, if you wind up with a red X in there, particularly on Windows 7 based machines, that was a very common error to get on the installer. MySQL tried for many months to correct that error. The best guess they gave anybody was just to go hit the back button on this menu and do it again, and 99% of the time it would go through the second time. MySQL couldn't answer that. With Windows 8 and 10, that problem has pretty much disappeared, so you should be good to go at this point. I would not expect to really see any errors at that point for the install. Again, you might get some error on the utilities. If that's a fail, don't worry about that. It will be fine. But in this case, you can see everything installed with no problem. And now what you're ready to do is install. You have to do the basic configuration of the server. And this is something you want to be careful about now. We want to basically make sure this should have already been set as a developer machine if you pick the development environment. But to enable TCP networking, which we will be doing, MySQL listens on the MySQL server listens on a particular port number for traffic that's dedicated to it. By default, that port number is 3306. And notice here that I have this at 3310. I have on my current system in my office about 6 different MySQL servers running. So for this class, I'm using 3310. It'll appear in all of the notes, all the examples. If you don't change it to 3310, you'll have to change it in all of the code examples that I upload, okay? Because the default is 3306. If you want to leave it at default, that's fine. Be aware that I'm going to be changing those numbers in the code. So bottom line is, it's probably easiest if you set that up to 3310 right now. But again, remember that number because you're going to use it a lot. If you haven't already done so in the setup or the reinstall, this is the point where it will ask you for the administrator password and username. Again, in this case, it tells me that's weak, and I'm fully aware of that, but it will accept it. Do not set up any user accounts at this point. We will be doing that through the workbench as we need them for some of our applications. And also do not enable, at some point you'll probably see in this, an anonymous account. Do not enable an anonymous account. That's a huge security hole in MySQL. MySQL Server by default on Windows machines runs as a service, so it will start up as you boot your machine. You can give the service a name so that you can find it maybe easily in your services. So I would recommend doing that. And when it runs as a service, then it will assume that you're using a standard system account, meaning you are the administrator at login, so you have administrator privileges on that account. At this point, you're basically ready to actually configure the server. It'll go through that, again, that process where it goes through all the setup. It'll finish, and at this point, if you click the little button or the little box here, it will actually start the workbench because, again, the installer has brought that down for you. And this is what the initial workbench window looks like, except that you won't see those 4 gray boxes there. I already have some instances, connection instances, on this particular server. What you will need to do, I'll show you this later, but you will click this little plus right here, and that's how you make a new connection. And the new connection will need a name and port number and all that kind of stuff. So here, for example, I have a client, I have local instance, MySQL. So this is kind of like a generic instance to come in. It's the root user coming in on localhost. So all these are running on the same particular server, and I just have different connection instances that I can go in and out of. For the time being, when you get this set up, you'll just leave one, and we'll create more as we go along. This is what the actual main workbench looks like when you come in, the kind of interface that you have. The main window is where you type SQL commands, enter scripts, whatever you're doing. Left side is basically the navigation pane through all the databases and tables that you have under the server's control. In SQL systems, MySQL specifically, you have to select the database to use. You cannot use multiple databases at the same time in an environment like this. You can do that in applications that will be different, but here you have to do one database at a time. So to do that, you'll basically click over here and simply highlight whichever database you want. All these directional arrows allow you to open and expand, what the tables and schema definition and so on look like. I have put out on the website on the courses a single script file that builds up a very simple byte database. I call it byte script, and to load that into the workbench, click on the File tab here, and one of the options will be Open Script File. So you just browse to where you stored that script file, click on it, and it will dump it into here. And then you click this little lightning bolt, and it will execute that script, and it will build the database for you. The script has a little query at the bottom of it that executes, and here is the result of that particular query. So when you have something executing in the window, basically the pane can split into 3 different areas. You've got still the area you're working in, the result pane, and in the bottom is always the output basically from the server itself, which is showing you line by line what actions are happening and so on. If you see again all these green checks, it means the command executed with no errors. It shows you a lot of statistics on the server side, how long each command took and so on, which for what we're doing at the time is not important. Later on, when we get into true enterprise cases, it will be interesting and important as to how long some of these operations take. So here you would simply type in a query, see the results, see the actions, and so that at this point basically means you've got your server installed and you're ready to go. You will also see that the installation of the MySQL server gives you a command line client. You want to become basically familiar with that. There are some things that we'll do later on in the semester that the command line actually works much better than the workbench. So when you simply start up the command line client, it's going to immediately assume that you're entering the password for the root user. To start the command line as a client user takes a little bit more effort. So it is assuming you have administrator privileges, that's the administrator password, and then you come inside, and what you are in then is a MySQL read eval print command loop. So when you see the prompt, it's basically looking for a MySQL or an SQL command. The first one that I gave here is simply the status, which is a brief summary of the server status. You can kind of see that stuff that dumps out there. And then it prints it out, and it comes back, and it's waiting for the next command. So I've issued several different commands here so you can kind of see how it works. In the command line, again, some of these are different variations of the server, so you're going to see different color screenshots and so on. But this is the way you see the databases in the command line by simply saying show databases. The SQL environment in general ends commands with semicolons, so we're pretty used to doing that from your programming environment, so that's common here. In the workbench, that's not required. It's going to assume that, so you don't have to put them in. So you want to kind of remember what you're doing back and forth. The database schemes that you'll see, these are the only 4 that are there by default. We'll talk a little bit more about them later on. But basically, the first 3 of these are all either server related or the database related, as the MySQL is where all the actual databases are. The test database by default is always empty. There's nothing in it. You can create things and put things in there, but MySQL doesn't do anything with it. Again, as you go along, we're going to be building up a lot of different databases, so your list of databases will get bigger. To use a database in an SQL prompt environment, the user can use and give the name of the database. In the workbench, you simply click, highlight the table, the database name. So like here, I highlighted that. As we get deeper into dealing with our enterprise solutions, again, keep in mind that the database is all back-end activity. The applications that we're using to provide the information or whatever the client wants to do need access to the database for the operational data that the application is using. So in a standard kind of enterprise application, if you think about, say, going shopping at Amazon, what are most of your activities at Amazon doing as far as the database would be concerned? The queries, you're looking at stuff, you're reading stuff out of the file, so what does this product look like? What does this product look like? Do you ever directly issue an update command? You don't ever actually directly issue a select command, do you? It's all done by the application. I say, I want to see this product. What has to happen in the background is I specify the name of the product, and then the query is generated to go off into one of their databases to find that particular product's file and bring in all the information, pictures, and so on to see it. Suppose I decide to buy that product from them. Now what's going to happen? Lots of things. One of the things that's going to happen in the background is there's going to be an update command that's going to say, okay, if we had 20 of those in inventory and this person just put one in the shopping cart, there's now 19 of them. Okay. In addition, I'm also going to put that shopping cart into some kind of memory in the database that's associated with my transaction, so I can add more things to it. And when I check out, then they're going to give me a bill and charge my credit card and all this kind of stuff. So a lot of database activity is going on in the background. But the point is, as a client, I'm not issuing a single one of those actual SQL commands. The application is issuing them for me on my behalf based on what I'm doing. And again, when you look at normal operational or transactional databases, there's a kind of a hard, fast rule in the database world called the 80-20 rule. You might have heard this in other kind of environments too. 80% of the people, or 20% of the people do 80% of the work. In the database activities, 80% of the activity on the database are queries. 20% are updates, inserts, replace, those kind of things. The thing that's important about that is that what we've just been talking about with all the multiple threading applications, suppose I have 10,000 people out across the world looking at this one product on Amazon right now. They're all just looking at it. They have all issued basically a query. Okay, do I need to synchronize those queries? Those 10,000 threads? Yes. They're just reading. They're not doing any kind of updates. Suppose somebody now wants to put that thing in their shopping cart. Now they got to be synchronized. Okay? So reads don't cause updates to the database. Reads don't need synchronization. They don't even need locks. Okay? But as soon as somebody says, hey, I want to buy that product, now we got a problem. We now have to lock that product. We have to make sure that if they actually put that product in their shopping account, suppose there's only one left, then we have to basically now tell the other 9,900 people or whatever that are looking at their product, sorry, they're not available now. Okay, assuming you checked out, not just put it in the cart. So these kind of things are important as to what's going on in the background. So all of this early part here of these nodes is simply just showing how to set up and use the database. Create the database from scratch, put the data into it, and so on. Where things get difficult for us, well, here is a simple select query on that byte table or byte database that I have the script for you. Again, I could have 100 million transactions issuing this query simultaneously. They're all going to see exactly the same results. Okay, but if one application says, hey, I want to delete this bike, now we need to synchronize those transactions because the next person that comes in and says, I want to see this table, they should not see the row that the person just deleted. Okay, because if they do, then our transactions aren't synchronized. They should not see the result of a database table until the result is actually permanent, basically. So that's going to get us up into the part here where, again, I'm skipping over a lot of this because it's just basic SQL that we'll see later on. But when it comes to creating a table, another very important aspect for enterprise applications is how is the table created? That is the structure of the database table. And this all comes back to essentially how is the table going to be used? And again, for the most part, when you think about what's going to happen, most people are just going to be making queries. They're going to do random searching on the tables. Random searching means that I might be searching based on a key. I might be searching on a non-key field. And if you remember from your database class, if I search on a key field, how many rows out of that table am I guaranteed at most to find? One. How many at worst case will I find? None. Nobody matched the key. But if I'm looking at a table with 100,000 rows and I'm searching on a non-key field, how many could I get in the worst case? 100,000. Every one unmatched. I get the entire table done back. I could also get 0 again. So the range of values that can come back from a query based on key or non-key values are very, very different. And that means that I have to structure the table in some ways to know how it's going to be used. So if it's a general purpose kind of table where I'm expecting just random type searching, the most common way to deal with that now in MySQL is called an INMODB structured table. And this is essentially what's called a transaction-safe table with row-level locking. So the synchronization that we've been talking about with locks, in an INMODB table, it's done at the row level. So each row in the table has a lock associated with it. Transaction wants to read that row, it has to get the lock on that row. It has guaranteed exclusive access to that row as long as it holds the lock.
Read or update?
Read. If I want to update the table, what do I have to do? I have to move my lock from the row level all the way up to the table. I have to lock down the table. And in a database world, this is difficult because suppose my transaction says I want to update the row with key number X. Okay? I can lock that row and do that update. But suppose my transaction says I want to update every row where the value of X is B. I have to lock the entire table because I don't know how many rows in the table have X value B. So there's a very wide range of how the table is going to be used. And these different kinds of tables are at least structuring the table somewhat for more optimal use on that kind. The two that are most common right now are IMMDB and MyISAM. A MyISAM file is a current variant of a very old structured table that IBM built in the 60s called an index sequential table. It's a hierarchical tree level table. It looks like a big tree. But it's a, remember from your data structures course that you do things with M-way trees? 2-3 trees, 2-4 trees, does those sound familiar? Nobody did anything with M-way trees in your data structures course? Well, okay, 2-4 trees are specific variants of a more general tree called an M-way tree. And an M-way tree, when you think about a binary tree, binary search tree, and you look at a node, you can go left or right? It's either greater or less than this value. In an M-way tree, you have M values in the node. So there's M ways out of the tree, out of the node. The idea is I don't want the search tree to be deep. I want it to be wide and flat. So I use an M-way tree to make it very wide, and I search in those nodes. And the reason for that is that starting at the top level of the tree to the leaf level of the tree, each one of those levels is a disk access in the database. And I don't want to go bouncing out to the disk 10 and 20 times. Keep that tree level short, and in an M-way tree with the right degree of M, you can make a tree that has 100 million records in it only be about 6 levels deep. We'll pick up here next time.